So, hello everyone. My name is Anurag, and very warm welcome to all of you first of all. And so today in this video, we are going to discuss about linked list and its real life use cases. So first, let me explain you what is a linked list. So linked list is a special kind of data structure in which there is a collection of objects resides. I mean, a linked list collects objects. It is a collection of objects that we can say it is a data type which keep objects together. So not every kind of object. It keeps some objects like if it is keeping any object, then it will keep the address of the next object. So let me explain you with some example. Here I can see there is a diagram of a linked list. You can imagine like a list is made up of multiple nodes. So this box you can see this we can say as a node. So we can refer to this and this we can say as a node. So it will be a node. So linked list is a collection of many nodes, and one node having two properties. First property is a data inside it. That what is the data we are saving into a linked list, and the next it is saving the address of its next node. Its next node it is saving the address. So this in this if we are saving a data here like I said, suppose we are having some variables, so a equals to let's suppose 10, so it is saving 10 here, and it is also saving the address of b. Let us suppose I'm also assigning b equals to 20, and so here it is also storing the address of 20, that is b. So here it will be storing that what is the next address. So let's suppose I'm giving the addresses here the address is 100, and here the address is 200, here the address is 300, or let's say here 100 it is 400. So we can say like uh, it is storing the address here. So this is the data structure of linked list, where it is just storing an object, and that object contains only two properties or variables. Like data first one is data, and second one is next element's address. So that is about linked list. So I hope the definition clear to you, all of you. And now let me come to the some use cases of it. That what are the some use cases, and let me give you a real life example and analogy. So to get into the use cases of it, first of all, let me explain why do we actually need it. So first of all, we need to know that why do we actually need it. So there is a problem with we have similar data structure. We refer that is an array. So in the array, we are having lots and lots of elements like 6, 7. I can store anything in the array 6, 7, 8, 9. I'm not talking about any specific programming language, but I'm storing some elements here. So yeah, these are some elements, and every element in the array have some index like 0, 1, 2 till and we are getting. So let's suppose in the array there is no if there is a lack of thing if I want to remove this particular let's say this particular, so what I need to do, I will be implementing some methods. Like if I want to delete this one, then I need to store from here to we need to store 6 in one array, and from 2 we need to store in another array. We will be storing it in another array. 8, 9, let's suppose 10 and 20. And after that we will be combining it together. So after that we'll be combining it, and we are and then we will be getting our result. So overall it is taking too much space also. Like we are getting order of n space complexity here. So it is taking space and extra time also. We are iterating through each and every element. So it is taking order of n time also. So it is not in the good terms of order of n in the time complexity or in space complexity. So to optimize that, what developers did, they introduced a data structure that is the linked list. So in the linked list, we are having the address. So with the help of address, we can remove the particular element. So I'm not going to explain in the deep, because this is the overview and analogy video. So yeah, so that were the advantages and that was the use cases of it. Oh, and let me give some real life example that where we can apply this. So have you? I hope all of you ever traveled with a train, travel by a train. So I hope this train is visible. So yeah, so you can see like there is a train. So in this train there are lots and lots of boxes, or I can say compartments. So these are lots and lots of compartments, and all the compartments are connected together by a chain. So in the chain, like if I am in this bogie and I want to go to this bogie, so I can go through the this chain. I can go. So this is the advantage of it. I mean, this can be a user I mean real life example. Or let's suppose there in the linked list we have seen like in the end element we are having a null mark, that it is the last and termination point. After that we are not storing connection to any of the node. So this null represent that. So same goes with the train, like you all of have observed the cross mark after the train. So that cross mark represent that like this is the ending of the train, and train terminates here. Train is not connecting any compartments anymore. So this is the cross mark here. So let's suppose due to some accident, some compartments are getting dispatched from the train, and train is running. So let's suppose train is going to the platform, and there is no cross mark on it. So TC or maybe some railway employees will see it that there is no cross mark. So they might be there are some compartment that are left behind, and they will try to contact that why it is happening, then what is the problem. So in that this is a user a real life example. And the second example I can say like a back button. So just I can show you the live demo here also, like undo, redo. I'm doing, I'm doing undo, redo. So yeah, this is keeping the next element's address. Like this was the next element. This was the next action. This was the previous action. So it is keeping the previous actions. It is storing the previous action. So I can say this is also implementation of a linked list. So that are some real life use cases. And let me talk about some extra information about it. So there are some extra information like uh, there is another kind of data structure which same like there is a existence of doubly linked list also. Like in the normal linked list, single linked list, we are having the connection to the next node. But in the doubly linked list, we are having the linkage of previous node also. Like we can go towards this side to this side, and we can go towards this side to this side. So train is an example of doubly linked list. We can say like we can move from one bogie to another bogie, and another bogie to previous bogie also. So that is the real life example of doubly linked list also. So yeah, that were some implementation and examples of it. So I hope you were able to realize the concept, and thank you so much for watching this video, and I hope you all are doing well. So yeah, that is all about it. Thank you so much. Have a nice day.